Hello and welcome to today's lesson. To get access to our starter pack files such as blueprints, technical primer PDFs, native CAD files, as well as exclusive master courses, join our community on Patreon at patreon.com/ArielCad3D. You'll find the link in the description below. In this lesson, we are finishing off this housing by adding the attachment for the U-bolt. And as I said before, we need the distance from the center to where the leaf springs are. And when we are deciding the distance between these 2 points, we need to account for the width of the leaf springs as well as the radius of the U-bolt. Let me show you an image so you understand what I'm saying. So we are designing these 2 U-bolts here, their attachment on this differential housing. So I'm saying you need to account for the width of the leaf springs, which in our case was 30 millimeters at the rear section, but also the radius, because half of the width of this U-bolt is also on the inside. So if we say this is going to be 10 millimeters, it means we have 5 on this side, 5 on this side, plus 30, which is 40. So we will add a gap of 40 millimeter in between, but we also need the distance from the center, and you can get that by going back to the model we created, the chassis assembly, and checking the distance between the plane at the center. Let's measure between the ZX plane and the edge of the leaf spring. So that's about 445.3. So you can go a little bit to this side, round off to this side, which will be 445. And we are saying we also need to add some half of the thickness of the U-bolt, which is 5 millimeters. So that will be 440. Okay, it will be 440. Then we will have 5 millimeters, 30 millimeters, another 5 millimeter, and the next U-bolt. Okay, so that's 440 millimeters. It's as simple as that. So if you go to your differential housing, back to the sketch that we were creating. Did I just close it? I didn't mean to close it. I'll just open it up again. Okay, here it is. So we're saying our width is 40 millimeters and the distance from the center to this first section is 440. So they're about this point. Then we need to pull them down. I would say about this point. Let's make it about that point. So the U-bolt, in this case, we are going to have it bent at the ends. So the U-bolt is gonna come like that, loop over the leaf springs, then up like that, and loop over so that we can have a bolt securing it, and on the other side as well. And at the bottom of the leaf springs, we also have a plate where these are looping into, but we will decide, we're going to model that in our next tutorial right after this one. So let's finish up with this at first. I'm hoping when I create a pad here, this hole is going to go all the way through. otherwise we'll have to create a pocket again. So now we are in the middle. Let me go to top view. You want it to protrude a little bit to this side and on the other side as well. Just want to confirm if yeah, we might need to create separate pockets for that. Let's see. Okay, it just means that I need to sketch it once again. And, you know, select these two circles, project them as a standard element, exit, and create pockets. Oh, limit 1 is already up to last. This one can be up to last as well. Now let's go with dimension and leave it on that side. And now we've got it through like that. I don't want them to protrude too much. And maybe I'm thinking I should add a material in between. I'm not sure. Material in between. No, let's just leave it as they are, as if they are welded or however they are forged together with this first element. Or add one that is separate. Let me see. I can add, let me project this one as a construction element so I get the point. I can create a rectangle like that, have an axis running through the center here, and make this to be symmetric about the axis. Symmetry. I want to reinforce these two so that they are more practical. Like that. Like, let's say they added more material when they are welding to reinforce it and make it stronger. That makes much more sense. I believe we are done here, but we need these bolts for this section. As I said, when it comes to nuts and bolts, majority of the one we are creating are illustrative features. They are not as if they would be manufactured. So we can just add it here as a fixed component, you know. We can add them as fixed components. I'm going to insert a point at these two circles so I can get insert a point there, insert another point there, insert an axis system, which is the same as the default one. and deselect current. Again, insert another axis system there. And I want to know the thickness. Measure between this and this. That is 13 millimeters. So our shaft is 13 millimeters. Now that I know that, I can sketch the first one, Z-plane. Profile. Then the same way we've been creating the bolts. I believe those holes were 5 millimeters each, but I'm going to confirm. They should be vertical. Create an axis. And we are saying this shaft. No. This shaft is 13 millimeters. What did I do? Let me undo that. Just need this line. To be 13 millimeters. And we need the radius to be 2.5. The height of the bolt head to be 5 millimeters. Did we sketch the wrong? We did sketch the wrong side. It's supposed to be along this vertical axis. Let me see. I can do everything. Delete that profile. So it's along the vertical axis. Like so. All right. This is going to be 5. This one too. This is going to be 13. Can give this one 2. Then we have the radius. This one is 5. Then this radius of the shaft. to be 2.5. Okay. Hopefully we've done the right thing this time around. So quickly, I just want to confirm if this radius is 2.5, so we are okay. And I can select this sketch, create a shaft. The axis is this Y component. I think I'm going to copy sketch 17, paste it here, and then change the sketch support to this one. Then create another shaft, and the axis is this one. We're going to leave them just as they are. We can hide the axis systems. The points as well. So when we are doing the assembly, before we do the assembly with the shock absorbers or the friction dampers, we will design this bolt and nut here, which will have a diameter of, what was it? Was it 15? Yes, radius 7.5. And for the leaf springs, the U-bolt, we've put, was it 10 or 15? 7.5. So both of them are the same. 7.5. So we can actually use the same bolt to secure these two. Although in this case, yeah, sure. We can use the same bolt to secure these two. But this one doesn't have a nut. It's just a threaded bolt. Maybe with a cotter pin or something. I don't know. Now that we've completed our attachments, we can create a mirror of current solid using the ZX plane. And the housing is complete. So next, the thing that we need to create is the lid. This lid, which is very simple. We just create a circle, a pad, another drafted and filleted pad here, some stiffeners, which we are going to have to do using pad because of this geometry, and some illustrative bolts here. So for the lid, we are going to insert a new body now. Insert a new body. And we can call it the differential cap. We are going to sketch this plane. And create a circle through the center. And instead of 30, I'm going to make it a bit less and make it 28 millimeters. What happened? What happened? Not 280, sorry. This was 300, sorry. 288. Yes, like that. 288. Create a pad. Let's see how thick is 10 millimeters. Five millimeters is reasonable, so I'm going to go with 5 millimeters. Let's give this a different material. Then sketch this plane. We're going to use an ellipse. This is 20. $200. Not sure why it's behaving like this. I have to let me try and do the other one first. Semi-minor axis. $160 by 200. Let me reduce this to 150. We are going to create something called a drafted filleted pad. I'm going to have a negative draft that is wider at the base and slimmer at the top of negative 15. Negative 15. The length is going to be 30 millimeters. The second limit is this plane. So negative draft. Lateral radius. Let's see, first limit radius. This one here. Let's give it 10. And second 15. And check. Let's see, second 10. And first 15. Yes. This, hold on. Let me see if I'm right about the drafting. Oh, so it's not supposed to be negative. It's because we are starting from here. It's positive 15. Wider at the base, narrow at. But it should be the same. It's just that when we add the fillet from this side, we increase the diameter here. When we add the fillet from this side, this diameter remains the same and it's supposed to narrow at this section. I'm not sure. Let me see. Yeah, I believe that. I will leave it at positive anyways. Okay. So now we've got that, and as I said, we are going to have to add those fillets. By ourselves. This can be just random. We can create a plane here, a plane here, and a plane here. Again, because even circular pattern will not work on an ellipse. So I will select a point This is on curve. Point right there. Or here. Another point on this curve. The reference should be this point. Okay. Then another point. Or I can do a line from this point and direction. Direction is the x-axis. Let's see. No, I said point and direction. So we can create a point, a plane using 3 points, through 3 points. And then sketch. Create a profile. Like that. Then we create a pad. So now it looks like we have a stiffener. So now to control the direction, you just simply have to, change this point. That was the whole point of adding 3 points. That you can make it face this side. By either adding or increasing. You see that? I think that's really cool. Then we can have another point. Can be on curve. Still this curve. And the reference can be this. Then you can have a plane. Through this point. And the reference is the XY plane. And then you can copy the same sketch that we had. Sketch 21, copy. and paste it. Did we paste it? Sketch 21, copy. Paste. Change the support to the new plane. Okay, that won't work well. Let's just create another one. At this point, again, it's just as simple as that. A pad which is mirrored. Total is 4 millimeters. I think we can mirror this. Let me see. Or instead change to GST workbench, mirror the sketch instead. Symmetry, sketch 21. Then create a pad. This one. So I was trying to create pads so that we can mirror all of them to the other side, because if I mirror this here, you won't be able to mirror again on this side. So you can have those three, and then you can select them. Use the ZX plane. And create fillets. Select all these edges. Like that. Select 1.5. I don't know if we should add fillets on these sections as well, but we can do it separately. If we want, we can do this separately. It's a continuous loop for each. So you only have to select one edge. I used the same 1.5. Hide the points. The plane and the line. Now obviously it's not a solid, it's not a complete solid like it is. It's supposed to be hollow. We are going to hollow this section to 5 millimeters. So select thickness. We want to remove this face. 5 millimeter of inside thickness. It's supposed to only cut out that middle section. I know we're getting an error. We should have done this. We should have done the thickness before we added these sections. That's why we are getting an error, because it's trying to cut out 5 millimeter from these sections as well. In that case, I don't know if it would be possible to just deactivate these sections. Deactivate. And create the shell. Like that. And perhaps move it up. I thought we usually have something to, you know, move this up. But let's see if I reactivate these sections. Oh, it's giving reorder. Okay. Let's try to activate them first. I don't want to have to redo everything again. Oh, no. We've got pad 13 to shell 2. So why are we getting an issue? External to the selection. Okay, I think I know what to do. You can delete the pads but leave the sketches. Okay, and then we can have our shell at this stage, like that, and then create pad using sketch 22, another pad using sketch 21, then another pad using the symmetry, using symmetry 3, then mirror those, like that, and add the fillets. It's a bit tedious, but okay. All selected. Last one. Let's have that and that. Well, there's a lesson there, and the lesson is if you're going to create a shell, we should do it before adding these additional features that we have here. I feel like I need to extract, go to GSD, first select all this, and deactivate. Extract that surface. Come back here and reactivate all this. Back to part design workbench. And then split using the extract. That didn't work, that didn't work, that didn't work. Extract, extract. I will just leave it as it is. It's not a big deal. And this is a bit longer than the others. Sketch 22. Can shorten it a little bit. All right, then we've got some bolts connecting this cap to the housing. About how many? 1, 2, 3, 4. And on the other side, 1, 2, 3, 4. So we need those holes, which are also about, is it 5? Might be 5 or less, because the bolts themselves, the bolt heads, look like they are 5 millimeters in diameter. But let's try. You can sketch this plane. So right near the rim, got one there. one here, five, select the two. This is what we mirror them using this axis. And again using horizontal axis. Yeah, something like that. Create pockets up to last. And we should also use that sketch. Copy. Don't know if we can paste it here at geometrical set. Paste it here, then go to part body. I'm going to hide the cap. We create pockets. Like so. Going to save my progress. Then I'm only going to create one bolt, and we're going to use it for all of them. And I'll just create it here using a different body. This is the differential cap bolt. So I'm going to create a point using the center of a circle on one of these. Insert an axis system right there. Sketch. In fact, I'm going to show the cap. So that I can project this edge like that as a construction element. Then create a profile, which is similar to what we've been doing. Hold on. I'm going to project this edge only. so we know the end. This and this should be coincident. Like that. Quick trim. Trim off the excess. We give the dimensions, starting with the radius of the shaft, which is 2.5. The radius of the bolt head and the nut, which is 5. The height of the bolt head, going to give it 3. Same with the nut head. Then create a shaft. The axis, let me make it black at the moment. Then we can create a pattern. I think I should have made that 5mm instead of 3mm. The height 5 for each. And I'm going to make this wider a little bit. So that it's more prominent. Now then sketch this top surface. I'm going to project the circumference like that so that I can snap the polygon. Like so. Let me redo that. It's supposed to be a standard element. We've been doing this over and over, so you should be comfortable with creating this. Okay. Then to make a pattern, you can create a user pattern by selecting this plane or surface and sketching it. And creating points. Hold on. Let me select this circle. This and project it. Create a point right there. Create another point. which is going to be coincident with this point. Coincidence. Then on the sketch, I'm going to select them from here, point 1 and point 2, and mirror them using the vertical axis. Then select all 4 points. Mirror them using the horizontal axis. Exit. Then create a user pattern. Current solid is okay. Positions, you are now going to select the sketch you just created. We have points. Those points, hold on. Again, sketch 27. All these points should be standard elements. That should be okay. User pattern using sketch 27. Perfect. Again, save your progress. Right, so now we've got the differential housing with a cap. On this side, we've got what we call a differential connect, which is sort of a cap like this, but instead of this short protrusion, we've got a long housing that's connecting, you know, all those gears all the way to the transmission. What's the other name for the transmission? The gearbox. All the way to the gearbox. So on this side, you can see we've got another cap which is also bolted, but instead we call this the differential connect. It connects this housing and its components to the transmission. So we've got that axle here that is rotating, then rotating the gears, converting this motion into this one that is going to turn on the wheels. All right, so in our next lesson, we can create this differential connect and hopefully now go to the U-bolts at the rear and the front section, create an assembly complete. We created the friction dampers before, we can now assemble them. And then we move on later on. I will tell you what we create later on. So I will see you in the next lesson.